Okay, so today we're going to be doing a pretty simple lab. I wouldn't call this a laboratory experiment, but I would call it more of a laboratory process that is really important, covered in the chemistry curriculum for high school. It's probably also covered, I'm sure, in living environment and earth science as well, and also very important to know for middle school science. And this is something that you should start talking about with even elementary school students. Is probably the best time to start talking about separation processes. Believe it or not, the process I'm going to show you today is very often a question asked on the chemistry regents, and it's very often missed by high school students. I'm not really sure why that is, but if you're at home, this is a really good time to address something that's so simple but so important for your child later on in high school. So what I'm going to be doing today is just showing you how to separate a very simple mixture, and I'm going to bring up some really good discussion questions to have with your child along the way. So all you'll need for this is some salt, some sand. It can be from anywhere. It doesn't have to be store-bought. This is, I think, from like a laboratory catalog, but it doesn't have to be. And a simple coffee filter and a couple of glasses. So what I'm going to do to start is I'm going to put some salt into a clear glass. It doesn't really matter how much. And I'm going to add some water to that. Again, it doesn't really matter how much, maybe in this case half a glass. Now, the first thing that you want to start talking about with your child is how do they know that this is a mixture? Obviously, the salt goes away. Well, where does it go? So what happens here is that as the salt dissolves, the ions that it's made out of, sodium ion and chloride ion, this is table salt, so it's sodium chloride, those ions are separating, and what they do is they sort of hide behind water molecules, and that's part of why they disappear. But you can liken that to, let's say that you tell your child for a chore to sweep the floor, and your child says, the floor's not even dirty, but you say, sweep it anyway, and they get sweeping, and by the time they're done, they end up with a pile of dirt and dog hair or whatever. Now, why couldn't you see the dirt before you swept it into a pile? Well, when it's spread over a larger surface area, you can't as easily see it with the naked eye. That's a similar thing here. So when we have a solid, and like salt or sugar, the particles are close together so we can see them with the naked eye. But when you dissolve them and they get hiding behind those water molecules and they spread out, you can't see them with the naked eye anymore. Now you might ask your child at this point, well, we know that it's dissolved because there is no more. I do have a little bit of solid salt left in there, but you could actually even make this go a little bit faster if you heated the water up first or used warm water to speed up the solvation process. But you ask your child, well, where did it go, and have a discussion about that. How do we know that the salt is still in there? And you might have your child just taste it, right? It's just salt water, so they could tell that the salt was still in there. You might then ask them, is there any way we could get the salt back out? Now your child might say no, especially if they're little, and there is a way to get it back out. I'm going to talk about that. And because we can get it back out pretty easily, that's how we know that this is a physical process, not a chemical reaction, okay? So again, that's dissolved in there. That's the first part. So you can have a lot of different talks about just the salt water being a mixture, a solution, before going on to this next part if you wanted to. So now the next thing that you'll do is you'll add some sand in there. And now the salt did dissolve. Salt is soluble in water. Is sand soluble in water? You can ask your child that. Clearly the answer is no. If it were, would we have beaches? Right? Have a discussion about that with your child. So here I stir it up, and you can let it settle out, and your child should see that the sand settles to the bottom just like it would at the ocean. Now you might ask your child, is there any way that we could get the sand out of there? And your child might answer yes, they might answer no, but what we're going to do is we're going to filter that out, okay? Now, this is a good time to talk about the difference between a homogeneous and a heterogeneous mixture, okay? This is very, very important when your child gets to high school chemistry. So homo means the same, hetero means different. A homogeneous mixture is one that has, I mean, there's a lot of stuff dissolved into it, but you can't see the different parts. So a good example of that is like Gatorade. Gatorade has a lot of stuff dissolved into it, but it looks like just clear red liquid. Or pool water, for example. Pool water's got a lot of different stuff in there. You've got chlorine or salt if you have a saltwater pool. Somebody might have peed in the pool, whatever. There's lots of stuff dissolved in pool water, but it looks like clean, clear water. That is a homogeneous mixture. You can't see the different parts. A heterogeneous mixture, on the other hand, you can tell by sight that it is a mixture, like a trail mix or a bowl of chicken noodle soup, or in this case, the sand not dissolving fully into the salt water shows us that it is a heterogeneous mixture, and you can start to see it at the bottom there settling out. That's how we know that it's heterogeneous. You can see the different parts. Heterogeneous mixtures tend to be easier to separate, right? A trail mix, if I told you to separate it by peanut, M&M, raisin, you could do that just by hand. That's actually a good skill to have a little like a small child do, learning how to separate things into categories. That's very important in biology, especially in earth science. So now to separate this out pretty simply, we're gonna filter it and just pour that right in there and hold the coffee filter in it. You wanna let the water drip out. And this process, which you can introduce your child to here, this is called decanting. So if you pour the liquid away from the solid as much as you can, leaving the solid in the bottom, right? That's called decanting. And then if you wanted to just go ahead and dump the sand right in there, you can, and that will catch in the coffee filter. And oops, my coffee filter fell down in, so you're gonna wanna do a better job of holding it than I just did there. But it will catch the sand in the filter, and you will have a liquid that passes through. Now, what you want to stress to your child here, as long as the coffee filter doesn't fall like mine just did, what should be in the cup now? The sand will catch in the filter. What will be in the cup? Now, the common mistake that high school students will make is they'll say that it's pure water in there, that the salt also caught in the filter. But did it? Well, if it's dissolved, it should have gone through with the water, the salt water. And since this is just sand and salt and water, I mean, we're not in a lab, you could have your kids taste the water and see that it's still salty, right? But they have to know that stuff that is dissolved will go through the filter paper with the water. I cannot tell you how many high school students miss that question on the chemistry regions. It is maddening. It seems very obvious, but it clearly isn't. So when they're little, that's a good time to start talking about this. And again, talk about the fact that there are beaches, right? But the salt water stays in the ocean and the sand stays up here. Sand will catch in a filter, but the salt water will go through the filter with the water. Now, when you reach this part, okay, ask your child again, is there any way that we could get the salt away from the water? And if you've been to the ocean before, remind your child, well, if you got out of the ocean and you were wet, covered in ocean water, and you dried off, and you were to lick your arm, right? How would your arm taste? Your child would probably say salty. Well, where did the water go? It evaporated, leaving the salt behind on your skin. So if we can evaporate this water, it would leave the salt behind. Now, there are a couple of ways that you can do this. I'm going to give you two recommendations. The first is you could dump this water into a pan or something and boil it and let all the water boil out, and you'll have like white powdery substance left in the bottom. It won't look like sugar or salt granules anymore. It'll be powdery. But you would evaporate all the water and it would leave the salt behind, because the salt is not going to, it will solidify again, crystallize. They won't be nice crystals though. If you want to get nice crystals, and this is awesome, and I wouldn't use this much water. This is a lot of water. I would take a smaller amount and put it in a glass or a plastic cup, something like this maybe. Okay, and I would leave it. Don't touch it. And it's going to take a while because water has strong intermolecular forces, so it takes a while to evaporate. Put it in like a nice, like a warm spot, even a sunny spot, and let the water just evaporate over time with all that salt dissolved in there, and you will see beautiful crystal salt formation in there. They form like perfect cubes. It's actually pretty incredible. And you can talk to your child about the fact that the water evaporated and left the salt behind, so that's a way to separate that homogeneous mixture. And you can talk about the formation of crystals. This can even link into something like if you've ever been to the Herkimer diamond mine, right? You could talk about how the diamonds form. That's exactly how it happens. You've got these ions or these salts that get trapped in the rock, and over time, when the water leaves very slowly, it allows, and again, remember I told you if it boils, you'll ruin the crystal formation. But if you let it happen slowly, it forms those nice, beautiful crystals. And that's how those are able to form. Very, very slow evaporation of water, leaving the ions behind, or the salts behind that form those crystals. And they become very beautiful if they're allowed the time to form properly. So again, this is separation of mixtures. I know that this isn't anything that's terribly exciting, but there's a lot that you can talk about with your child, and it's very important for when they get to high school science. So I am working on some other more exciting things for this week. I hope that you like this activity. You can do, if you want any extensions for this activity, just reach out and I can give you even some more questions to go along with it. So enjoy.